Now let's start with the Docker today. Okay, and Jenkins is not yet over. Okay, like Jenkins will come back again for do when we integrate with the Docker. We write a Docker pipeline. Okay, when we return for the like a Docker freestyle job pipeline job. Okay, like as integrate with the nexus, like as Docker image to push to nexus repository, Docker image push to the ECR repository. Okay, there is a different kind of pipeline code we're gonna write in further again. Okay, let's understand the Docker today concept. And this Docker and Jenkins, there is no dependency. You can easily understand even though you are not practice the Jenkins. Okay, now from today, like you should be practice for this Docker the day we discussed. Okay, because this Docker commands is same as our Git commands. Okay, it is similar only. Okay, but it's very simple and straightforward, but you have to be understand the whole concept of containerization. Okay, the whole concept of containerization, how it is important in the real time now, why it is more important, and why more like as most of the companies are being using this Docker. Okay, understand the terminology. Okay, first of all, before Docker, understand the problem. Okay, what is the problem statement? Okay, why we need Docker? First of all, okay, the problem statement is that, for example, if you want to deploy one Java application, why we need, what are the things we require? We require a one Linux mission to deploy. Okay, this Linux mission, but my Java application, let's say maximum let's say few, like 100 MB, let's for example, let's say 100 MB application I have, and I want to deploy this 100 MB application. Now you need to take a one Linux mission. Linux mission, if you take, basically if you are going, because nowadays we have a cloud actually, right? The cloud we are using for 8 GB, okay, and then 1 GB RAM, 1 GB CPU, right? Even though that won't work if you get a more request, right? And previously, before cloud, we have a VMs, right? Virtual machines we have. Virtual machines means people, virtual machines where we used in the on premises. We discussed, if you remember correctly, like when we discussed about the cloud computing, like as introduction session, I talked about what is on premise, what is the like as in, like as like as SaaS, PaaS, like as right, infrastructure as a service, IaaS, right? Like as platform as a service, software as a service, we talked about, right? Now similar here, like as okay, okay, can you see my screen, guys? There is some small uh, internet connection issue. Okay, guys, confirm me. Can you see my screen and can you hear me? Okay, fine, thanks. Okay, now like as we have to use for our on-premises to deploy our application. Now, like people are using for VMs to deploy application. VM means it's a virtual machines. It's a virtual machines. Okay. Now, what do you mean virtual machine? Like as they will take a big server. They divide that big server into small servers. Okay, and they will deploy application. They will use that resources. Like for example, they will buy a, like a petabytes kind of server, and they divide into small, so like 250 GB, 500 GB, something like that, one server, and they can use for on top of it one virtualization, like virtual machines. Okay, like as VMware, something they install and they manage those servers actually. They restart, stop, or spin up something. Now to spin up this virtual machine, we can use a like as there are a lot of tools, the vSphere, okay, Oracle VirtualBox, Oracle virtual machines are there, Oracle virtual machine, VMware, okay, VM players. There's a lot of tools, like there's a lot of softwares are available to create a virtual machines. Okay, what is the virtual machine means? Like is to create a one Linux mission. Like they will take a big mission, on top of it they will create a small Linux mission. For example, let's say you have Windows mission. For example, let's say on top of Windows mission, if you want to install Linux, you can install without uninstalling your Windows mission. Okay, to install Linux mission, what you need, basically you need to install any one of the hypervisors. Okay, we call it as a hypervisors, call it as a hypervisors. Okay, we call it as a hypervisors, right? Now this hypervisors means, what are the hypervisors? The one we are talking about. Okay, like these are the hypervisors we called. We need to install these hypervisors. After installing installing these hypervisors, we need to take any one of the base guest OS. Okay, guest OS means, for example, you want to install a event tool, you want to install a core OS, you want to install a CentOS OS. Okay, any kind of Linux flavor you want to install, that OS you need to be installed. Okay, that OS you need to be installed. After installing OS, what you need to do, you need to be install application libraries, application like software, like for example, you want to install a Java application, Java software libraries you need to be installed. Then after that, you need to be install an application. After that, you need to be run your application. Now to do this, okay, look, to create a one virtual machine through these hypervisors. Okay, now this guest ways to install, we need at least 20 GB hard disk, one CPU core, CPU, one CPU core, one CPU core, one core CPU, let's say one core CPU at least. Okay, and 1 GB RAM at least, minimum 1 GB, 2 GB RAM is mandatory for to create a one Linux machine on top of your OS, on top of your like a Windows operating system, Windows operating system. Now to avoid this, because your application is just 100 MB, but you want to be like, for example, this much VM to create, this much VM to create. Now what happened? This all the storage is wasted. Yes or no? It's not being used, right? It's all your resources will be wasted. To avoid that, to avoid the resources, now the Docker come to the picture. The main thing is that to save resource. And another important thing is that, okay, another important thing is that to make deployment more faster, installation, configuration. Okay, nothing required. Okay, like installation, configuration, nothing you need to do. It's a simple Docker file you write, it will be installed, it will be configured, it will deploy, it will be install OS, all everything to run your application, whatever it is needed, everything we can keep it into one file. That file we can run, it will create a one small Linux mission to you, one small Linux kind of, okay, small Linux mission, it will be created for that. That mission we called as a container. That mission we called as a container. Okay, like whatever we need, installation, configuration, okay, whatever applications, everything we are written into the single. Now here also we reducing this time for reducing okay, installation configuration time actually. Okay, installation configuration deployment time. Okay, deployment time. Now how much time we are saving means, now it's a like weeks to minutes. Okay, like to deploy your application, it's a minutes of time now. Okay, if you want to deploy your application, minutes of time now, that you can feel that when we are doing that hands on. Okay, now it's a weeks to, sorry, in weeks to minute we are reducing time to installation, configuration, deployment in application. How we are saving this time, that we can see in the hands on. Okay, that you will be realize that okay, this is the what exactly the Docker will do. Let me take one small
Okay.
example.
One
Yeah,
question here. So you're saying weeks to minute is the time which is taken for installation, configuration, deployment. All the time will be reduced to minutes.
correct, correct.
Okay,
Okay,
not for the only
it's
deployment step. Right? Okay.
no, everything like as even the guest, like even see these are also creating guest OS, installation guest OS, no operating system installation, no VM to take, no VM to provisioning, no networking configuration, nothing required, nothing required. It will be everything is done in a single file. If you build the file, create an image, run your application, that's it. Now within a minute your application will be up and running for you with the whatever you want that OS, whatever you want that application softwares, whatever you want that application dependencies you want to install, everything. Okay, that
Okay.
how to do that,
And
that's what we need to learn the Docker. Okay, that
okay.
we can do this.
What are the cloud computing we do, right? That serve the same purpose, right?
Cloud computing is for to provide a Linux machines for you. Okay, like before the cloud computing, we have a on-premises. On-premises means it's your own Linux machines, like as you know, by the your organization. Your organization need to spend lot of money for that. Even if you are
Yeah.
using
Yeah.
are not using. Okay, for example, if you want like a 8 GB instance, you won't buy the instance that outside, right? No, you should be buy like as GBs of data, like GBs of Linux machines you can buy. You won't get 8 GBs of, it will be given memory card to you, not for the Linux machines, right? Now, to like as to avoid that maintenance, like not only buying, like I you have money, you say like as I don't have a money problem, I have a lot of money with me. Okay, like after taking money, it's not only take like buying a server. That server you need to be
Maintenance.
take care like your baby. Okay, like as you need to
Right.
be networking team, you should be recruiting, and networking servers you need to be recruiting 24/7, up and running, that AZs and everything you have to be take care of. If you see, if you go for any big organization like IBM or something like, like a Citibank or as like Verizon, something like that, right? They have dedicated Linux mission server room they have. Okay, in that server room you have seen that like as all the servers is up and running for this. That is like as our own called as a on premises. Fine. Now that you no need to take care of, like let me give you one example. Okay, for example, let's say to install a Ubuntu Linux mission on your Windows mission. Okay, like as for example, how much, like even this Ubuntu software, how much size it is anyone download Ubuntu software from internet anytime? Yes, is anyone downloaded Ubuntu software? Is anyone downloaded for Ubuntu software? No, no. Okay, let's try. Yes, I'll take a ISO image for downloading. This is desktop. Instead of desktop, even we have like ISO images two for two. Okay, like for example, let me download this. Don't, this is something along with this. Okay, if we take, okay, let me show you. This is along with the like as along with the desktop also. A desktop you end up. Okay, like even if you don't want desktop, at least it take a minimum 2 GB. Okay, minimum. How much it is GB is downloading now? How much GB it is? 4.7 GB, right? 4.7 GB. Right now, I'm just stopping this. You can observe this, right? Now, to download this Ubuntu in a normal Linux machine, normal VM, this much size. It's like not 4G, like not ISO image, it will be less, but this desktop is bit more actually. Okay, but it around like a 2 GB will come, like 1 GB for minimal version. At least if you go normal flavor, it will come 2 GB without desktop. Okay, now 2 GB at least minimum will come. Okay, it's including desktop. It is this much size is more. But if the same Ubuntu run as a container, okay, this is a like plain Ubuntu. Okay, normal container. Okay, container Ubuntu. Okay, let's say container Ubuntu. I mean Docker Ubuntu. You can say. Tell me, expect the how much size it is. Even you can run same, what are the options, what are the commands you can run for normal plain Ubuntu, it's the same command will work here, but the few libraries is whatever it is not required, it is not installed by default, you can install if you need. Okay, like for example, you want see the IP address, if config command, IP addresses, okay, net tools, even those things if you need, then you can install yourself. Okay, but if Ubuntu you want to run as a Docker Ubuntu container, how much CP just expect? No, it is like at least at least 2 to 3 GB, let's say for example, right? Now, if it is Docker Ubuntu, like just guess it, how much it is, how much it can be. Just guess. Okay, 200 MB. Okay, no, it's just 80 MB. One Ubuntu container you want to run, it will take just 80 MB, and even this also is more. We are not using real-time scenario Ubuntu. We are using, there is a one more flavor of Linux machine which is available for containerization, that we are using a one Linux flavor, that flavor called as a Alpha Linux. Okay, what is the flavor? Alpha Linux. Just guess how much size it is. Just guess it. Just guess it. Okay, it less than the your photo size. It's just 5 MB. One Linux Ubuntu container is like 5 MB. It's a just 5 MB. Okay, we can see and we can use that also. We can run our container also. We can see that IP address of that container also. Everything and so on. Okay, but yeah, just I'm giving the just information to you. Just remind this, remember this. Like when we do the hands-on, then you realize that. You realize that. Okay, fine. Now just I'm giving the overall like as idea of that why we need Docker. Why we need Docker. Okay. Now I hope you guys understand that what is Docker main purpose, right? Basically, there is a two things. One is that to reduce your deployment time, like not only deployment time, like installation, configuration, deployment time, and second is that to reduce your resource resource utilization, right? Now that is the main two scenarios we are using a Docker. That is the two scenarios only. The entire industry is like is wasting their time, the wasting their money, the wasting their like as whatever you can say, like as resource, money, time, everything, right? Note the Docker is filling out all these gaps actually. Okay, that's the reason it is more boom in the industry right now. If you go for any company, any organization, they must using the Docker right now. Okay, that kind of like as value in the Docker in the market. Fine, we'll see. We'll learn in depth. Okay, we'll learn each and every command in the Docker. Okay, most of the things we can learn. Okay, let's see. Okay, first of all, like as to understand this, why we need this. Okay, basically, right? No, basically, understand. Okay, let's I can take you through for one simple Docker uh, real pitch actually. Okay, what is the real case? Right now, real use case. So, for example, let's say okay, like as what is a Docker basically? Like as we just call as like Docker is a simple, lightweight, like as resource utilization to deploy your application, right? Similar way we can define the one simple statement for Docker. Okay, Docker is a containerization platform. Containerization platform to build, ship, and run your application with lightweight resources. Lightweight resources. Okay, that is a definition we can define. Very simple, like no critical. Like as even if you go for what is Docker official documentation. See, Docker overview. You can see Docker is an open source platform developing, shipping, and running application. Docker is enables to separate your application from your infrastructure, and you can deliver the software quickly and see deliver software quickly. With the Docker, you can manage your infrastructure within the same ways to manage your application. But taking advantage of Docker is methodology to shipping, testing, deploying code. You can significantly reduce the delay between the writing code and running into production. Okay, that is the main scenario. Okay, the Docker provides the ability to package, run application loosely isolated environment called as a container. We'll talk about the container. Okay, what is the container? Okay, fine. Now just go through this official document page. What is the overview? Whatever we talk, just understand that. Okay, it's very simple. Okay, we'll talk about this Docker architecture later. But before going to discuss about the Docker architecture, first you need to be understand the what is the real case. Okay, for example, let's say okay, in your real life, okay, you are currently working on let's say for example you are currently working in one city. Okay, like as I'm in working in Bangalore right now, for example, let's say. Okay, I got a job in, let's say, some I got a like a Hyderabad or Chennai, let's say. Okay, like I have a lot of things there in my home. Like I have like two cars, three bikes, okay, a lot of like equipment in the home. I want to ship everything. How can I ship this? Like I can use a multiple travels in that case, right? Like you have multiple cars and all, right? Instead of that, there is a option for us, right? There is a big containers. Yes or no? One container we can keep it everything and we can ship it, right? You guys are seeing, right? Like there's a lot of containers are there for if you go port area, there is big containers are there. Like even if you want to export cars from one country to another country, how they were shipping, like, right, they were shipping to big containers, right? The similar way, right? Now that container that we call as a, like, as to shipping something. Similar way to up to software side, okay, to run your applications, okay, in a Docker we call as a container. What is container contents? Its container contents include everything. It's include everything means, for example, like OS, application related properties, like as configuration files, and like as execution commands, everything whatever required to run your application, everything they keep it into one place and run as a container. Run as a container. Is got it right? Got it right? Let me show one example, okay? In real scenarios, like for example, like previously how they do, they want to create a one database, one like as front end application, okay, like as some message brokers, okay, different things they are running, different Linux machines, right? Even you guys are observe also, like Nexus, SonarCube, like Tomcat, okay, Jenkins. We running on a different Linux machines. Have you seen that, right? But still I am dedicated that Linux machine for that application, right? Right. Even though I use for the small amount of resource, but still I'm gonna keep it that service run up and running, right? Now in a containerization level, not like that. We are taking one Linux machine. On top of Linux machine, everything we run, like as in a single container means it's a individual application only. It's not everything in the single application. Nexus, like as Jenkins, like as SonarCube, everything we can run is a one container, one container. Like it will take very less resource on top of your kernel, like as kernel resource for your Linux machine. Okay, kernel resource of your Linux machine. Let me show that one simple documentation to make more understand this, okay, which is provided by the official documentation. Okay, now let me show that. Had very nice documentation this. Let me show that. Right now this is what I just talking about. Okay, now for example, let's say you have a lot of things to shipping, like as you can use like different kind of travels to ship many things, right? Now instead of that, similar way software side, to run you like as user DB, queue, analytics, endpoints, web front end, static application, backend workers, multiple softwares needed to run your application. Now we can run in the VMs, like different clouds, different Linux machines, and all we running. Instead of that, now what we are doing, we are keeping into everything in the one container. We are using a any one of the like a big vehicle to shipping that. Is clear, no? Understand that real pitch of why we need containers, right? Instead of running one place, now instead of that we are keeping everything and we running into one place, right? Now see this. This is given by the official documentation. Okay, that nice examples, right? Now similar way, like instead of static website, user DB, front end, queue, analytics needed for run your application. Now we are keeping in the one container. We run any one of the server, any one of the server, not all servers. Is that clear now? Understand, guys? Real pitch you guys got it, right? Real use case, like real life and this. Okay, now let me show that here simple. Now, first of all, understand this why we need Docker another way also. Okay, if you remember correctly, okay, like as if you go for 2010 or 12, that time, even when I'm studying, okay, when I'm learning Java course in 2013, right? No, that time what we the people are teaching for me, like as it's a, like as there is no web services there, but not a microservice. Okay, web service means what they do, they are entire application they deployed, but their dependency service running on somewhere else. We are calling through JSON request and response, right? Now means entire MVC application, like as model view controller, everything we deploy into a single application. We write a one simple one repository to deploy entire application. Means people are, like for example, if you deploy in a single repository, people they may have dependency from one developer to another developer, because alright, that guy will give the output, then only I'll take that output and then I'll process it to database, right? No, there is a dependency from one member to another member in the team. Instead of this, nowadays what happened, right? The entire that are like entire one project we call as a monolithic application. We call as a entire all MVC application, we are keep it into one source code and then deploying called as a monolithic application. Now instead of that, nowadays what happened, right? The industry, like is moving ahead. Instead of using a monolithic application, they are using a microservice. Okay. Now why we need these microservices? Basically, there is no dependency. Like for example, let's say I'll give the one scenario, real scenario. Okay. For example, we have a red bus, abi bus. Okay. For example, let's say not only that, even that whatever you can see that even page app, you can say phone pay, google pay, paytm, everything. If you guys are observe, right, a paytm, right, paytm started their business with their mobile recharge. How many people are knowing this? They just started for their paytm for mobile recharge application. Anyone knows this? They don't have anything before this, no, except recharge. No, others no, don't know. I think maybe you guys are kids, huh? Okay, fine. Okay, like as like Paytm initially they started with their business with the recharge only, mobile recharge, right? And going day by day, they increase their business. Entire the world they keep it into one application now, like a shopping, train ticket, hotels, like as everything in a single place. Even you can order like as what are the application, food, everything is available in the like as in Paytm, right? Directly. No, that means they have a individual services that, okay, they have individual businesses that, no, individual microservices that they are included into the one application. Now, for example, let's say take a red bus, okay, to register your, to log in to log in your red bus account, there is a one service. After login your account, then for example, let's say you want to book a bus, that is a one service, and payment is another service, and cancellation is another service, refund is another service. There is people are implementing a different microservices, they called via HTTP, right? They will be called HTTP or TCP, that depends on their application models. Okay, people are using those kind of request response, they will be get and they will be call it, right? Okay, leave it about all these things. Okay, let's take our real life. Okay, for example, I'm just giving that how the microservice web service will work. Okay, just I'm giving one example. For example, let's say you have a ICICI bank account ATM, like as you have account in the ICICI bank, but in nearest your place there is no ICICI ATM. Okay, there is, you have a Axis Bank ATM you have, or HDFC Bank ATM you have. Now you go on that ATM, you can withdraw your money. Like how it possible? Because of you don't have a account in your that bank, right? How you can still you are able to access that? How, even though that HDFC Bank or Axis Bank, they don't have your data, they don't have your data, like as how much money you have, what is your pin number, what is your card details, what is your account numbers. They don't have data, but still they are able to give money back, like as when you withdraw money, right? How it will happen? Like basically when you insert the card, it will read the data, it will be asking for the request, like as what are the card in, like as it's related to the card bank. Okay, it is the ICICI bank, it will go ICICI bank, it will be request, it will send, right? This is the people came to my ATM, and then these guys are requesting this amount. Okay, this much is the card details. Is the card details correct or not? Yes, is card details correct? The next, how much amount you want to enter the amount. This amount is available or not? Yes, it's available. Then it will be allow you to withdraw. No, these many request calls will happening over the internet. Over the internet, maybe them ICICI bank people are using for a Java based application, and like as an HDFC bank are using a .NET applications, for example. It's still they are able to communicate via this HTTP protocols, like via this web services, right? Have you guys have think about this how it works? No, right? Before, this is the main thing, like the people are using a web services, they are sending a data request, they are getting a response, and with the like response, like either soap web services or restful web services, right? These are the web services. That services is divided into small services called as a microservices. Okay, that web services divide into a small piece of services, like I just mentioned you, right? For example, login page, registration page, cancellation, ticket booking, payment, everything is the one services. They will call that service will call another service will call that another service, will give finally your response. Are you got it, right? In case, let's say for example, in the development side, that guy is no need to depends on you. That guy implement his code, his deploy his application, take a dummy data, sample dummy data, he will be process his things. Like as he can deploy his microservice in case, if you want to deploy application, the whole application no need to deploy, the specific microservice only need to deploy the specific microservice only, it will be failure. The previously like his entire application will go down, like even nothing is work for you. But right now, if application not working means maybe one piece of thing not working in the application, every remaining everything will works. It's clear, no? It's clear, guys. No, that's way it is in a microservices design. Okay, now to deploy these microservices, to deploy one, to implement one application, there is a 400 500 microservices are there. Means 400 500 like as repositories they are maintaining. To deploy this many repositories, and you no need a 500 Linux machines, right? Now we are running a like as 500 containers within the two missions, right? Now this will be save your time, resource, everything. It's clear, no? Understand, right? Now see this how the industry before that. Okay, before people are not only about that. Okay, like not only microservices. Nowadays people are don't have patience first of all. Okay, because the industry like that our life will be running like anything. Okay, it's running more than speed on clock, right? Basically, for example, I'll give the one scenario. Okay, you went for one biryani like one hotel. Okay, you order one biryani. Okay, like in case the guys will be take more than 30 minutes. Are you guys are still wait in that biryani for biryani? What you guys do? You guys, the nearest, like as if there is another shop near to you, you will go to that shop. How many guys are did this? Anyway, in the real life, these are all like right. The same way, the software industry also. People are like they expecting the output immediately. They don't want to wait for a month, years of their output they want to see. Now, for example, let's say one guy came, and I need this application. How much time take? 2 months, 3 months, 4 months, 5 months. Like give me the months, okay, not for years. And every, even in the 5 months, he won't sit simply. You will ask that out like as update. Hey, what happened? What, where we are right now? What is the 30 days data? What is the 45 days? What is the 60 days? What is the 75 days? Every 15 days called as a sprint, right? That with the people will be asking for the new updates for their application. At the end, they have something to show. They release that kind of data in the market. Hey, we are ready. No, this is the features are available for my application. Okay, like this is what we are going to implementing this. No, people can be started using that. If started using that, they can be in the market right now, and they will be improving that, like as performance issues, bugs. Okay, and then they are going to adding a new features, blah 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 things. Okay, that will be go on a next level of releases. Is that clear? No, that's what the industry is working. Okay, now before the industry how look like, it's the entire monolithic application that called as a like as old legacy applications. Long development life cycles, long development cycles they are taking. Single environment, only one environment they're maintaining. Slowly scaling up, like as if you want to make any new features or new thing, they will take it slowly. Now, decouple services, elements microservices, fast iterative improvements, multiple environments, dev, staging, production kind of, and quickly scaling out. If you want to increase, you can like as even you no need to touch manually. Automatically it will be scale out or scale in. Okay, if you want to increase, it will increase. If you want to decrease, decrease automatically based on the load. For example, if you remember, if you want to either big billion days, okay, like the sales will happen either in Flipkart or Amazon, right? Okay, like as that day, like as if you can see, that application should be scaled, or else whatever it is running on a normal days, it won't work out. That should be scaled based on the load. Okay, that even that we can see that we can learn that going forward actually. Okay, like when we discuss in AWS course, we'll understand that how the scaling will happen in the instance level, how the scaling happening for the application level in a Kubernetes and all, we can see replica set and then HPA, all those things will come to picture. Okay, now that's things actually. Like as you know, this is the where we can the people are improving their application at how much load is happening. Your application should be work. Now maybe that kind of, there is some government applications we are facing issues, right? For example, let's say you want to book a Tatkal ticket. Okay, how many guys are facing issue like as server unavailable, server not responding? You guys are facing issue, right? Why? Because people are using more people that time, like nowadays is somewhat improvement like previously. How many guys are facing this issue? Not only that, like as any, like as for example, submitting some applications. Okay, even the tax at the last moment, tax returns, like you want to like e-filing. Now at the last moment it won't work. If not work, they will be extend some more data, like till that, like last year they will be doing the same thing, but this year they are not did that. They will, only one data actually. Yes, like it was before, right? Now it was somewhat they changed, they somewhat they are improved their application. That's what happening, right? Industry. That's the reason, we need a quick scaling out, a scale out, a scale in. Scale out means increase, scale in means decrease. This spellings are different. Okay. Out means increase, in means decrease. Okay. Okay, result of Docker. See, this is the main thing. Dev to production, reduce 9 months to 15 minutes to deploy your application, and a single nothing. One commit done. That will go to the either every station, like as in every stage, like as the application clone, build, compile, testing, deployment. One environment. It's everything is fine. Let's move to the different environment. That environment. That like a pre-prod UAT and then production. That's it. It will go for like it's very fast way. Continuous integration job time reduced more than 60%. Okay. Dev to production from weeks to minutes. Like development environment to production environment, earlier it takes a weeks of time. Now it won't take a weeks. It's a just a minutes. Just a minutes. That is the result of Docker.